Right, grade 11s, we're on our second day of sequences and series, and we're going to talk about arithmetic sequences. So if you have a sequence such as 1, 3, 5, 7, and so on, where the difference between consecutive terms is constant, 2 in this case. You have an arithmetic sequence. The number added to one term to produce the next is called the common difference. Number added to one term to produce the next. There. A couple of examples for you. For instance, -3, -5, -7 would be an arithmetic sequence because we would constantly add -2 to produce the next term. So it would continue from there, -9, -11, and so on. 15, 12, 9, and 6 also would be an arithmetic sequence because we're constantly adding -3. It doesn't have to be negative, just the examples that I've chosen happen to do so. So it is an arithmetic sequence. The next one, 0, -5, 10, -15. It appears that you would add -5, but then to go from term 2 to term 3, you would be adding 15, and then you would be adding -25, and since you're not adding the same thing each time, it is not an arithmetic sequence. It might be something else. We could write it as a recursive formula to generate next terms, but it's not arithmetic unless you have a common difference. The example 5, 9, 13, 17, 21, 25, and so on. Our n values are 1, term 1 is 5, term 2 is 9, the third term 13, and so on. The expanded version of this particular term would be just 5, and then 5 plus 4, because we're adding something on to the first term to get the second, and then 5 plus 4 plus 4, and so on. We constantly add 4 more each time. Can I fit enough here? There we go, 1 more. And so on. If you were to write that in a more compact form, we have our initial 5, and then we have a 4, a single 4, and then we have 2 4s, and then 3 4s, and 4 4s, and this should look familiar, 5 4s, and so on. So our general term for an arithmetic sequence is you have your initial value, and then you have your initial value plus a common difference, and your initial value and 2 common differences, and 3 common differences, and so on. To write it as a general term, it would be my general term equals, so I can just put that in brackets as an aside, my general term is my initial value plus 1 less than the term number of the common difference. So for instance, term 6 would have the initial of 5, and then 5 4s, not 6 4s, but 5 4s. Determine the value of the 45th term, T45. So for the 45th term, I would have my initial value and 44 D's. For this particular example, I would have a 5 and 44 4s. All right, 5 plus 176 is 181. That's a lot more efficient than writing them all out. So to recap it as a summary, your general arithmetic sequence is always, sorry, didn't mean to put a plus sign, the initial term, the initial value, sorry, add a common difference, add 2 common difference, add 3 of them, and so on. And the general term would be the initial value and 1 less than the term of the common difference, where A is the first term, D is the common difference, N is the position or the term number, sixth term, seventh term, and T sub N is the value of the nth term. First example, an arithmetic sequence has first term 3 and common difference -5. Find Tn. So the general term is your first term and n minus 1 times the common difference. So you can write it exactly like that. We could tidy it up a little bit. Distributive law would be -5n plus 5. Final answer 8. Take away 5n. Find T21. So the 21st term would be 8 take away 5 times 21. Or the 21st term is my initial term and 20 of the common difference, -5. Either one will get me to the same place. So 8 take away 5 times 21 is 105 minus 103. No, minus 97. 3 plus -100 minus 97. For the following arithmetic sequence, determine Tn and T15. So my general term. Well, let's write a couple things down. First of all, my first term is 4. My common difference is going up by 3 consistently each time. Do a quick mental check. Yes, consistently up by 3. So my general term would be 4 plus n minus 1 times the common difference of 3. And we can tidy that up. 4 plus 3n take away 3 would be 1 plus 4n. T15 is 1 plus 4 times 15. 61. Got it. Did you? 3n. 1 plus 3n. 1 plus 3 times 15, 46. So we got that T15 from our general term. If we had decided not to tidy up and write our general term like that, you can always get the 15th term from the first term and 14 of the common difference. 4 plus 42, which is 46. Find the number of terms in the following sequence. So 2, 5, 8, 11, and this one ends at 488. We can sit down with a piece of paper and write every last term, but I'm thinking that wouldn't be a lot of fun. So let's see if we can come up with an equation. First of all, we know that our first term, or A, we can call it either one of those two things, is 2. My common difference, and it's going up each time, is 3. So I can come up with a general term for this. Tn comes from the initial value plus n minus 1 times the common difference of 3. My general term is the number 2 plus n minus 1 times 3. Well, that's as good as I can get it. I guess I could have a little tidy up if I wished, but Tn equals 2 plus 3n minus 3, 3n minus 1. I want to know what number of terms would get me to all the way to 488. So if I substitute 488 Tn, I can solve for n and find out which term is the 400 and it has the value of 488. Let's add 1 to both sides. 489. Divide both sides by 3, and I got 163. So T 163 is equal to 488. There are 163 terms in this sequence. Insert 3 numbers between 10 and 55 so that each successive term is increased by a common difference of d and fit in between evenly from 10 to 55. Well, we know we're going to have 10 and 10 plus the common difference and 10 plus 2 of the common difference and 10 of 3 of the common difference and 10 of 4 and the common difference, which happens to be 55. So I can use that last relationship to figure out what that common difference is. So if 55 is equal to initial value plus 4 of the common difference, 45, I'm going to subtract 10 from both sides, divide both sides by 4, and I will get 11 and a quarter. 11.25 is my common difference. So I can find the other values by substituting 11.25. So the next second term is 10 plus 11.25 is 21.25. 10 plus 2 of the common difference would be adding 11.25 onto that one, would be 32.5. The next one would be 10 plus 3 times 11.25, 43.75. And the last one is 55. Need to try some? Page 424.